Not only can segments be bisected, but angles can also be bisected. And so let's talk a little bit about an angle bisector. Here in this diagram, we've got angle BAC, and then I've got a ray AD that is going right down the middle of that angle. And that is an angle bisector of angle BAC. When an angle is bisected, it is divided into two congruent angles. So the rotation here on angle BAD is equal to angle DAC, and so those angles are congruent, and this is a bisector. One of the things that we notice about bisectors, if I have a point on the bisector, like we'll just use point D right here, no matter where I put point D, the distance from point D back to either one of these segments, and by distance we mean the shortest distance, is always the same. Let me demonstrate how we know that. Let's draw some perpendicular lines. I'm going to draw a perpendicular from here to point D, and then from to this line from point D, and then I want to put some points here. So I'll put a point right there at that intersection and a point right here at that intersection. And now I don't need these lines anymore, so let me just get rid of them. And instead, let's replace them with some segments. Okay, so segment, and then a segment to here. All right, so the distance from point D to ray AB and ray AC, which are the sides of the angle, that distance is the length of these perpendicular segments. And if I measure that length, we can see that for both of them, that length is the same. And that happens anywhere on that bisector. As I move point D along, point D is getting further from each of the sides of the angle, but it is always the same distance from both sides of the angle. So any point on a perpendicular bisector is the same distance from both sides of that angle. And the reverse is also true. The converse is also true. If I have some point, if I tell you that point D is the same distance from both of the rays of an angle, then you know that point D is on the perpendicular bisector. That's what these theorems tell us. The first theorem is the angle bisector theorem. It says if a point is on the bisector of an angle, then it's equidistant from the sides. So if I know that ray BF is the bisector of angle DBE, then I know that the distance from point F back to either one of those rays is the same. So in other words, segment FB must be congruent to segment FE. And the converse of that just simply says that if I happen to know that segment FD is congruent to segment FE, then I know that point F must be on the perpendicular bisector in order for that to be the case.